So in this video, we're going to go through lesson 3-4. So we're going to start with our prep skills. So in our previous lectures, we've learned just what those inequality symbols are, the less than, greater than, and then you could add the equal to. So think of if you want to write the set of all numbers less than or equal to 5, that would be less than or equal to. So you indicate an X to say it's less than or equal to 5. If you want numbers between two possibilities, you can write what's called a compound inequality. So the values of our variable can be somewhere between 6 and 12, but you can't equal those options. If you have this expression, t is greater than or equal to 8, that means you're letting any real number greater than or equal to 8. Y less than 4, any value of y that is smaller than 4, so 3, 0, 1.5, 1.999, those all satisfy this inequality. And you could absolutely have equal to on one side and then a strict inequality on another. So if you have this case, you could equal -3, but you have to be strictly less than 2. So you could pick any number in between that, but you could also include -3. Okay. The second thing is we are going to be working heavily with these inequality symbols. So remember, it's like an alligator mouth. The alligator wants the larger quantity. So this symbol would mean that the thing on the left is greater than the thing on the right. This tells us it's pointing to the bigger one, so it's indicating less than. And when you put a bar underneath, all that means is it could also equal that specific quantity. And then the third one, we've talked a lot about combining like things. So you want to combine like pieces. Remember, x squared and x are different because they're different quantities. But if we have different cases like this, so we're going to start with 2 times x plus 4 minus 5x. First thing you're going to do is use that distributive property. You're going to distribute the 2 out. So you get 2 times x, which is 2x. 2 times 4 is 8. Then we're going to combine our like pieces. We have 2 x's. We're subtracting 5 x's. So in total, that gives us -3x. And then the 8's on its own. We don't have any other constants, so you just bring it right down. Okay. In this next example, we have to distribute this minus sign before we can combine like pieces. So we get -3y minus 5. Now when we go to group our like things, we have 4 y's and we're subtracting 3 of them. So that leaves us with a single y. We have positive 10 as our constant, -5. So in total, we're left with 5. So that is as simplified as we can possibly make this expression. All right, and then finally, we learned a bunch of tools last time that will go through how we can solve an equation. What this lesson is going to help us do is solve inequalities. So our 4 main tools we had is you can add the same number to both sides of the equation, you can subtract the same number, you can divide, or you can multiply. And this will not change any solutions to an equation, but you can apply any of these. Just be careful in using that distributive property. So what we're going to begin with is we're going to deal with quantities that aren't necessarily equal. So maybe you're thinking you want a specific salary, you're looking for a job, or you're potentially wanting to leave your job. You're making $40,000 where you are right now. Anything acceptable is going to be something over that quantity. So you want more than that. So we want to figure out ways to solve these inequalities. So we're going to start. Let's think of a number that makes x greater than 3 true. So we want a value for this variable that makes x greater than 3 true. You could pick a whole bunch of things. 7 works. So 7 is definitely greater than 3. That works for us. You could pick something else. You could pick 5. You could pick 100. All of those are going to work, okay? If you want to pick a number that makes x greater than 3 false, you could pick 2. If you pick x to be 2, 2 is definitely not greater than 3. This is a false statement. You could pick something else. X equals 0 does not satisfy this inequality because 0 is definitely not greater than 3. These are both false statements, okay? So this will help us when we're going to check if we did something right. We knew in the previous linear inequalities or linear equations that we could plug it back into the original and see if we got a true solution. So these are those 4 main tools we had in that last one. You can multiply both sides, divide, add, or subtract, and it's not going to change the solution to any of your equations. Okay? So now we want to come up with, does the same thing hold? We've got a different symbol in the middle. We've got an inequality sign. Can I do exactly the same things, and will it change any of our solutions? So we're going to look at some examples. We're going to start with exactly the same comparison. So in all of these, 10 is less than 20. That is a true statement. What we're going to start with is we want to add 8 to both sides. So if we take 10 and add 8, we get 18 over here. You add 8, you get 28 over here. And your inequality wants to go towards the larger thing, so it's going to go towards the 28. So it doesn't change the inequality symbol. Now if we add negative 8, 10 plus negative 8 would be 10 minus 8, so you get 2. 20 plus negative 8 would be 20 minus 8, so you get 12 over here. Same thing, the inequality goes towards the bigger one, so it's going to go towards the 12. Okay? Now if we do subtraction, if we subtract 6 from both sides, 10 minus 6 is 4, 20 minus 6 is 14. Same thing, inequality goes towards the bigger quantity, doesn't change, it's in the same direction. If you subtract negative 6, I'm going to do that down here, 10 minus negative 6, remember the minus turns into a plus, so you get 10 plus 6. Subtracting negative 6 would give you 16. Same thing over here, if you take 20 and you subtract negative 6, that's 20 plus 6, so you get 26 here. And the inequality symbol goes towards the larger quantity, so it does not change. Okay? So if you notice, when we add or subtract, regardless of whether it's positive or negative, nothing happens to our inequality symbol. So this is our first tool. Add or subtracting the same number on both sides of an inequality does not change the direction of the comparison symbol. So just like we could add or subtract on both sides of an equation, you can do the same thing with an inequality. So let's try to do some examples. We want to find values of x that satisfy x minus 5 being greater than 9. And we want to use this tool where we add or subtract and it won't change anything. So what we can do is we're subtracting 5. Let's go ahead and add 5 to both sides. That's 15. 5. So that will make the 5 and negative 5 cancel. And what we're left with is x is greater than 9 plus 5, so 14. So the values of x that satisfy this inequality are values that are bigger than 14. So 14 is our important point. We have that strict inequality. So I cannot actually equal that point, so we're going to have an open circle. But then every value after this is going to be good. We want values of x that are more than 14. Okay? So now we want to go back and we want to check, is this actually correct? So we're going to pick something in this interval and see if it works. So let's go ahead and pick 15. That's in that interval. We're going to plug it back into the original equality and see if we get a true statement. So we're taking x, which is 15, subtracting 5, and we want this to be greater than 9. So that leaves us with 10 is greater than 9, which, yes, that's definitely a true statement. So we've done this correctly. Okay. So let's do another problem. We've got t plus 11 is less than or equal to 5. You want to get t by itself. So we're adding 11. So let's subtract 11 to cancel it out. So 11 minus 11 disappears. So what that gives us is just t on this side. The inequality sign will not change. And 5 minus 11 is negative 6. So negative 6 is our important point. I can actually equal this one because we have that bar underneath. And then I want values of t that are less than this. So anything to the left will work. So we want to check by picking a value that is in here and seeing that it does satisfy the equation. You can pick whatever you want. I'm going to pick a number that's nice to work with. Let's pick t equals negative 10. Plug that in. You get negative 10 plus 11. That needs to be less than or equal to 5. Well, negative 10 plus 11 is negative 1, or positive 1. That's definitely less than or equal to 5. So yes, we did do this correctly. We have the same solution, or correct solution. Right? So these are some really nice tools that we can use. So let's keep working with it. So we're going to write a verbal description of what each solution set to the two inequalities actually tells us. So if you look at this first one, our solutions are any values of x greater than 14 causes this original inequality to be true. So it causes x minus 5 to be greater than 9. So this first one's done for us. Any value of x greater than 14 causes the original expression x minus 5 to be greater than 9. So if we try to do this for the second example, any value of t less than or equal to negative 6 will cause this expression to be less than or equal to 5. So what we can say for the second one is any value of t less than or equal to negative 6 will cause that expression on the left, which is t plus 11, to be less than or equal to 5. Okay? All right, so that is our first tool. Now we're going to go through and we're going to try to figure out our second tool. So for linear equations, we could multiply both sides by any number that wasn't 0, divide both sides, same thing. we're going to see, is that going to hold true for inequalities? So we're going to start with exactly the same true statement, 10 is less than 20. We're going to take this statement and multiply both sides by 2. We get 20. 20 times 2 is 40. So good. Inequality still stays the same. 40 is the bigger quantity. Now if we divide by -2, or multiply both sides by -2, 10 times -2 is -20. 20 times -2 is -40. So we've got a problem here. This -20 is actually closer to 0 than -40 is. So this is the bigger quantity. So our inequality symbol is going to actually have to flip. It wants this larger amount. Okay? So let's see if that happens with division. Let's take this inequality, divide by 5. So 10 divided by 5 is 2. 20 divided by 5 is 4. So same thing, this inequality doesn't change. Now when you introduce that negative, 10 divided by -5 is -2. 20 divided by -5 is -4. So same thing happens with the negative number. It causes it to flip. Okay? So this is our second tool. When you have a negative number, you're going to have to flip the sign. If you multiply both sides by a positive, it's not going to change. So if you multiply or divide both sides of an inequality by a positive number, the direction of the comparison symbol stays the same. However, if you multiply or divide both sides by a negative number, the comparison symbol changes. So it has to flip when you deal with negative numbers. So let's go ahead and give that a try in a few examples. We've got 2 times x. To get rid of the 2, you divide by it. And since it's a positive number, nothing will change. So 2x over 2 just leaves you with x. 10 divided by 2 is a 5. And because it was positive, sign stayed the same. So 5 is our important number. It's strictly less than, so we have a circle there. And we can equal anything to the left. So if you want to check that, you want to pick a number that falls in this green interval, you could pick x equals 0. If you plug that in, you get 2 times 0 is less than 10. 0 is definitely less than 10. So this works. Okay. Now if we look at the second one, we want to go ahead and we're multiplying by -3. So we're going to go ahead and divide by -3. To get rid of that piece out front. So all you're going to be left with is a z over here. 12 divided by -3 is -4. But since this was a negative number that we divided by, that inequality sign has to flip. So 4 is your important number, -4. You can't equal it, so we have, or you can equal it, sorry. We have a closed circle there, and we can pick anything over here. So if you want to check this solution, you want to pick a number that's less than -4. Let's make it something easy. -10 definitely falls in there. So you want -3 times -10. This needs to be greater than or equal to 12. -3 times -10 is 30. 30 is definitely less than or equal, or greater than or equal to 20. So we get a true statement. So now let's try our second type. We're going to multiply to be able to solve this inequality. So we've got 1/4 times t. Let's go ahead and multiply this side by 4. So the 4 times 1/4 cancels. Same thing over here. Make those disappear. So all you're left with is t, and then -3 times 4 is going to be -12. So that is our important number. We cannot actually equal it, but we can pick any value greater than it. So to check, let's pick t equals 0. That falls in it. 1/4 times 0 needs to be greater than -3, and 0 is definitely greater than -3. So we've solved this correctly. Now, over here, we've got -1/3 b. We want to times this by -3 to be able to not only cancel the minus sign, but to just be left with b, which means we're going to do the same thing over here. So these cancel out, and you're just left with b. 2 times -3 is -6, but can't do that. Gotta flip that sign because it's a negative number that we're multiplying by. So we get b is greater than -6. -6 is our starting point. I could equal this, and I can pick any value greater than it. So if you want to check if it's true, let's pick a nice number. Let's pick b equals 0. You get -1/3 times 0 needs to be less than or equal to 2. Anything times 0 is 0, so we get 0 is less than or equal to 2, and that's definitely a true statement. So we are good. Okay? So here's a summary of all the different steps that we have. What you want to do is you want to simplify as much as you possibly can. You can add or subtract both sides of the equation by the same thing. And it won't change the inequality sign. But if you're going to multiply or divide by a negative number, you do have to flip that comparison symbol. So just be careful. Because when we were dealing with equations, that didn't matter. But inequalities, it being negative, makes a difference. So now we're going to go through the group exercises together. We're going to head back to that same old snow cone business. And so what we were able to come with in the last time is our profit function, which is nice and conveniently given to us right here. So remember your profit, starting out when you sold no snow cones, you had that fixed cost of $245, so you were automatically in the hole -$245. And then every single snow cone you sold, you got a 63-cent increase. So this was the profit function we were able to come up with in the last lesson. So now we want to write an inequality that will help us figure out what profit would have to be, or we want to write an inequality that states in symbols that the profit for this business will be at least $100. So we want our profit to be at least $100. But the profit is exactly -$245 plus 0.63 times x. So we want this expression to be at least $100. So what we can do is we can solve this inequality. So if we solve for x, this will tell us how many snow cones we actually need to make a profit of $100. So we've got to reverse everything. We're starting with this, and we want to apply these tools we just learned to solve for x. So I'm going to avoid dividing by this 0.63 first, because you would have to do it to every single piece, both of those. First, I'm going to get the x by itself. by adding 245 to both sides. That'll make these cancel, and then we'll just get a number times x. So we're left with 0.63 times x needs to be greater than or equal to 345. And then our other tool told us we can divide by 0.63 to make these two cancel. And the inequality sign is not going to change. This is going to give us x is greater than or equal to 547.6. So if we graph this on our number line, we've got 547.6. You can equal this number, and anything bigger than it will be a solution to the inequality. Okay? So let's go ahead and show that one value in our solution works. So let's pick 600. That's definitely greater than 547. We're going to plug this back into this original inequality. So we get negative 245 plus 0.63 times our value of x. This needs to be greater than or equal to 100. So if you simplify over here, you'll find out you have 133 is greater than or equal to 100. So yes, this is a true statement. We definitely did check this and get the correct solution. So what this actually tells us is any value of x greater than 547.6 will satisfy this inequality, which means your profit is going to be greater than $100. So if you sell $548 or more snow cones, will make a profit of at least $100. So that's what our solution set means. Now, if we look at a different inequality, we're going to try to figure out what this means. We've got negative 245 plus 0.63x. That's exactly this profit function. So this means the profit is less than 0. So in words, this inequality, or the solutions to this inequality, tells us how many snow cones we would sell to lose profit, or to lose money. Okay? So any value that satisfies this inequality tells you your profit is less than 0. So the company is losing money. So now let's go through, and just like the last example, let's solve this. So let's find the values of x, or the number of snow cones that we would need to lose out on money. So we've got negative 245 plus 0.63x is less than 0. So our first tool, we want to get the x values by itself. So we're going to add 245 to both sides. So this way those two cancel. then we've got 0.63x is less than 245. So we get x by itself, divide by the 0.63, divide by the 0.63, and if you do that, those two cancel, you're just left with x, and on the right hand side you'll get 388.9. Okay. So any value of x less than that satisfies the inequality. So here's 388.9. You can't equal it, but anything less than it will work. So let's check we did this correctly. Let's pick a number and see if it works. So 300 definitely falls in this interval. So let's see if it satisfies this inequality. So we've got negative 245 plus 0.63x, which is 300. That needs to be less than 0. So if you do that, you'd get negative 56 is less than 0. So yes, this solution works. So these solutions, any value that falls inside this interval is going to tell us that we are earning negative profit. So if we sell less than 389 snow cones, our business will lose money. So our business will have a profit of less than $0, so we lose money. So you need to sell at least this quantity to have a positive profit. So now we're going to take a turn and work back with our Fahrenheit conversions we did before. So the temperature inside a room housing servers is important to proper function. So what we need is that the temperature should have to stay in some type of range. We need the room temperature to be below 50 degrees, or it should not go below 50 degrees Fahrenheit, but it can't exceed 82 degrees. The optimal temperature range is going to be between 60 and 71. So as long as it's somewhere in between these quantities, we're going to be good. So we want to write an inequality that expresses the statement the temperature should not dip below 50 degrees Fahrenheit. So our temperature, we don't know, it's going to be F, but it should never get below 50. So we want the temperatures to be greater than or equal to 50. It can't go below this quantity. But maybe suppose our thermometer or thermostat only reads in Celsius. So we want to see another inequality that relates to degrees Celsius that will satisfy it. So Fahrenheit, you can write as 9/5 times degrees Celsius plus 32. So instead of this Fahrenheit, I'm going to replace it by the expression that involves Celsius. So this is the same as saying 9/5 times the degrees Celsius plus 32 has to be at most, or at least 50. So any value of C, which is the degrees Celsius that satisfies this equation, will be good for our temperature. So now we want to go ahead and we want to solve it and see what that tells us. So we've got 9/5 times degrees Celsius plus 32. The smallest that temperature can ever get is 50. First thing, we want to get the C variable by itself. So we're adding 32. So let's go ahead and subtract it for those two to cancel out. So you get 9/5 times C is greater than or equal to 18. Now we need to get rid of this 9/5, so you could just divide by it. Just be careful how you input this into a calculator. But those two will cancel, and you're just left with C. When you take 18 and divide it by 9/5, you're going to end up with 10. Okay? So as long as the degrees Celsius is at least 10, then the Fahrenheit will be at least 50, and our room temperature will be good. So this tells us the server room should be at least 10 degrees Celsius. All right. So now we want to look at the other expression. We were told that the temperature should not exceed 82 degrees Fahrenheit. So at most, the Fahrenheit should be 82. That is the largest. We shouldn't get to 83, shouldn't be 90 degrees in here. So we want to, again, be able to see, well, if the Fahrenheit can be at most 82, what's the largest degrees Celsius that we can possibly be? So remember, our conversion is the Fahrenheit is 9/5 degrees Celsius plus 32. So all we're going to do is instead of this Fahrenheit, we're going to put our expression that involves degrees Celsius. So this tells us 9/5 C plus 32 needs to be at most 82. But again, this now gives us an inequality that we can solve using these tools to figure out what is the most the degrees Celsius should be. So we want to solve this inequality by using this same process. We want to subtract 32 to get rid of it, which means we have to do it to the same side, and it won't change the inequality. So we're left with 9/5 C, and then 82 minus 32 would be 50. You want to get rid of the 9/5, so you could divide by it. Another thing you could do is multiply by 5/9, because the 5s would cancel, the 9s would cancel, which means you have to do exactly the same thing to the other side. So you're left with C is greater than or equal to 50 times 5/9, which if you plug into your calculator is 27.8. So what this tells us is the server room should be at most 27.8 degrees Celsius. So now we're able to combine these two things together. The server room should be at most 27.8 degrees Celsius. And we also know it should be at least 10, so it has to be stuck between these two quantities. So if we write this in a single compound inequality, our degrees Celsius needs to be at most 27.8, but it can't be below 10. So our degrees Celsius is stuck between these two. In terms of Fahrenheit, from the original statement, at a minimum, the room had to be 50 degrees Fahrenheit, and at a maximum, it should be 82, right? So what we can actually do, instead of going through and solving these two separately, we really could solve this inequality in one shot using that conversion rate. So instead of this Fahrenheit in here, we're going to utilize that F is 9/5 C plus 32. And we're going to see by solving this compound inequality, we're going to get the same range up here. And we're going to be able to do it in one shot instead. So our Fahrenheit needs to be between 50 and 82. But the Fahrenheit is 9/5 C plus 32. And at most, this can be 82. So basically we're solving these two things at once. You want to get the value C by itself, so you want to subtract 32 to make these cancel. But if you're doing that in the middle, you've also got to do it to both sides of the inequality. So that gives us 50 minus 32 is 18. 82 minus 32 is 50. And then all we're left with in the middle is 9/5 times C. Okay? And now you could do exactly the same thing. You can multiply by 5/9. You can divide by this 9/5. And that will make these two cancel, and you end up with the same results. You still get 10 is less than or equal to C is less than or equal to 27.8. So yes, this still gives us the same inequality. So instead of going through both of them at once, you can just go through a single straight shot to solve both of them instead.